Welcome back, number theory enthusiasts. We're continuing our deep dive into the OEIS, the Online Encyclopedia of Integer Sequences.
Always a pleasure to be back.
Today, we're going to tackle a sequence that might look familiar at first glance. It's A000128. It starts off 1, 2, 4, 8, 16.
Looks like powers of 2, right?
Yeah, you'd think so, wouldn't you? But then it throws a curveball with the sixth term, 31.
Ah, yes. The OEIS loves to keep us on our toes.
It sure does. And this sequence is classified as a nonlinear binomial sum, which might sound a little intimidating.
Well, it can be, but it's also super fascinating.
So could you break down nonlinear binomial sum for us? What does that actually mean?
Sure. Think about the binomial theorem, where we expand A plus B.
Right.
A nonlinear binomial sum is like that, but imagine throwing in a few extra terms that don't quite fit the pattern.
Oh, okay. So it's like the binomial sum took a detour.
Exactly. These extra terms are often fractions, and sometimes the variables in those fractions cancel out, leaving you with a constant term.
Interesting. So AN000128, with that unexpected 31, is an example of this detour, a nonlinear binomial sum.
Precisely.
So what makes these nonlinear binomial sums so interesting to number theorists? What's the big deal?
Well, it's that unpredictability, that deviation from the norm that makes them so exciting.
Okay, I see.
These nonlinear binomial sums, like A000128, often lead to unexpected connections and reveal deeper mathematical relationships, things you might not see at first glance.
Okay, that makes sense. So what kind of connections are we talking about here? What surprises does A000128 have in store for us?
Well, for starters, there's a fascinating link to, get this, the Fibonacci sequence.
Wait, the Fibonacci sequence?
Yep, the one and only.
Wow, I wasn't expecting that.
You can actually express the formula for A00000128 using the Fibonacci formula, with a few tweaks, of course.
That's incredible. Are there other hidden relationships lurking in A00000128 we should know about?
Oh, absolutely. Remember those extra terms we talked about, those detours?
Yeah.
Well, if you look at the differences between consecutive terms in A000128, you get another sequence, A000126.
So the way the numbers change in A000128 is connected to another sequence.
Exactly. It's like a sequence within a sequence.
Wow.
And guess what?
What?
If you take the differences, again, the differences of A0000, notice you end up with a sequence that's super close to Fibonacci.
No way.
It's A000007, which is basically the Fibonacci sequence, but shifted down by 1.
So we've got A000128 connected to A000126, which is connected to Fibonacci.
And there's more. Remember those binomial coefficients?
Yeah.
Well, A000128 follows the same difference equation as them.
So the sequence A000128 is like a key to understanding Fibonacci numbers, binomial coefficients.
You got it.
It's like it holds a secret code to unlock these fundamental mathematical concepts.
It really does. And while A000128 exhibits these remarkable connections, it also has its own unique identity. It has its own set of formulas for calculating its terms.
Okay, that's cool.
One of these formulas uses those Fibonacci numbers we talked about, while another relies on recursion.
That's really neat. So we have explicit formulas to calculate any term in A000128, huh?
Yep, we do.
It makes you wonder, who figured all this out? It's not exactly obvious that there be this link between A000128 and these other concepts.
It really highlights the power of observation and ingenuity in mathematics, and for those who love generating functions.
Ooh, generating functions, always intriguing.
A000128 has a particularly elegant one.
They do feel kind of magical, encoding an entire sequence into one expression. I'm definitely curious to hear more about A000128's generating function and what makes it so special.
Generating functions are a powerful tool in number theory. They really capture the essence of an infinite sequence in one compact expression, like a blueprint.
It's pretty amazing, right? Can you give us a taste of that magic with A000128's generating function? What's so special about it?
Well, the generating function for A000128 is 1, 2x plus by 2 plus by 3, 1 by 2, 1 by 3.
Okay, I see it. But how does the jumble of symbols actually generate our sequence?
Imagine expanding that expression into an infinite power series. Each term in that series would match up with the term in A000128.
Oh, I'm following so far.
And the coefficients of those terms, the numbers in front of the powers of x, those would be the actual values in the sequence.
So by manipulating that generating function, expanding it, and looking at the coefficients, we could get the whole sequence.
Exactly. It's like a recipe for A000128 baked right into that expression.
That's incredible.
And what's really elegant about this particular generating function is its structure. See those terms in the denominator?
Yeah, 1 by 2 and 1 by 3.
Right. Those hint at the connections we've been talking about.
Oh, I see it now. 1
Yeah.
by 2 looks a lot like the characteristic equation for the Fibonacci sequence. And 1 by 3, that feels like it's related to binomial expansions. It's like the generating function itself is telling us about those hidden connections.
It's a treasure trove of insights. It doesn't just give you the sequence, it tells you how it relates to other ideas.
Mind-blowing. This is really making me appreciate the power of generating functions. It's incredible how much information is packed into one expression.
They're pretty amazing tools, and A000128's generating function is a great example of how seemingly different areas of math can come together in unexpected ways.
Yeah, speaking of intersections, we've talked about A000128 connecting to other sequences and concepts. But where might we encounter A000128 outside of pure math? Does it have any real-world applications?
That's a good question. While A000128 itself might not show up directly in everyday life, the ideas it embodies, binomial sums, Fibonacci numbers, recursion, those are fundamental to a lot of fields.
So understanding A00000128, even though it seems abstract, could actually help us understand these broader concepts that do have real-world significance.
Absolutely. It's like a microcosm of those concepts, a playground to explore them. And you never know, sometimes discoveries in pure math lead to practical applications later on.
That's a good point. It's amazing how interconnected everything is in math. Exploring a sequence like A00000128 is like traveling through a web of mathematical concepts.
It really is. It's like a tapestry, and A00000128 is one of the threads.
It's a reminder that there's always something more to discover, even in a sequence that seems simple. We've only scratched the surface with A000128. Who knows what other connections and properties are waiting to be found?
Each exploration leads to new questions and new avenues to investigate. And with the OEIS as our guide, the journey never ends.
Exactly. It's a treasure chest of mathematical wonders.
Hmm.
So for our listeners who want to delve deeper into A000128, where should they start? What resources would you recommend?
Well, the OEIS itself is a fantastic starting point. The entry for A000128 has tons of information, formulas, references, links to related sequences. It's a goldmine.
And beyond the OEIS, are there any books, articles, or maybe online communities where folks can connect with other number theory fans and learn more?
Oh, definitely. There are so many books and articles out there on number theory, Fibonacci numbers, generating functions, and online you've got forums, social media groups, all sorts of places where mathematicians and enthusiasts gather to exchange ideas and explore together.
It's amazing to have that global network to learn from and collaborate with.
It is. And never underestimate the power of your own curiosity. Sometimes the most rewarding discoveries come from just playing with numbers, patterns, and ideas. The OEIS is a great playground for that.
That's so true. Anyone can be a mathematical explorer. You don't need a fancy degree to find something new and exciting.
Absolutely. The world of numbers is open to everyone, and the OEIS is a great gateway to that world.
This deep dive into A000128 has been truly enlightening. We've seen how it connects to Fibonacci numbers, binomial coefficients, generating functions. It's been a great example of the beauty and interconnectedness of math.
It really has. And it shows how even a seemingly simple sequence can have so much depth and inspire further exploration.
And for our listeners who want to continue that exploration, we encourage you to check out those resources we mentioned. Dive into the OEIS, play with the formulas, and see what patterns you can find. Who knows, maybe you'll make the next big breakthrough.
And if you do, be sure to share your findings with the community. The OEIS thrives on collaboration and the exchange of ideas.
Well said. So that wraps up our deep dive into A000128. We've come a long way from its simple beginnings, exploring its connections to Fibonacci numbers, binomial coefficients, and generating functions.
It's been a great journey showcasing how a single integer sequence can open a window to such a fascinating world of mathematical relationships.
Thank you for joining us on this exploration of the OEIS. Until next time, keep searching for those hidden patterns and enjoy the thrill of mathematical discovery.
Happy exploring.
It's fascinating how much we've uncovered in just one sequence. But before we wrap up, I'm kind of curious. We've seen the connections to Fibonacci and those binomial coefficients, but could there be other famous sequences hidden within A00000128, just waiting to be discovered?
That's what's so exciting about the OEIS. There's always that possibility.
Right, like what if there are more secrets to uncover?
Oh, absolutely. Mathematicians are constantly looking for these connections, and every time one is found, it opens up a whole new world of questions.
So A000128 could have even more to teach us.
Definitely. Think about it. There could be ties to prime numbers, geometric sequences, concepts we haven't even thought of yet.
Ah, the possibilities are endless.
That's what makes this field so exciting. There's always something new to explore.
It's amazing that a sequence that seems so well studied could still have so much more to reveal. Makes you feel like there's so much left to learn.
It reminds us that math is constantly evolving. You never know what you might find. And hey, maybe one of our listeners will be the one to uncover the next hidden connection in A0000000128.
Now that's a challenge I'm sure our number theory enthusiasts would be up for. To all our listeners out there, keep exploring A00000128. Dive into the OEIS, play with the formulas, who knows what you might find.
You could even make the next big breakthrough.
Exactly. And if you do, share your findings with the community. It's all about collaboration and exchanging ideas, right?
Absolutely.
Well, this brings us to the end of our deep dive into A000128. We started with what seemed like a simple sequence, but wow, we uncovered so much.
It's been quite a journey, from Fibonacci numbers and binomial coefficients all the way to generating functions.
Yeah, A000128 really highlights the beauty and interconnectedness of math. It's amazing how a single sequence can open up a whole world of relationships.
It's been a pleasure exploring it with you.
Thank you for joining us on this OEIS adventure. Until next time, keep those minds curious and keep exploring those patterns.
Happy exploring.